Hi, my name is Sydney Shelby, and this is my project on particle motion. When you're talking about particle motion in calculus, you're going to be talking about three main things. So that's position, velocity, and acceleration. So we're going to go and talk about a little bit about each of those. Okay, so the position of a particle is the location of the particle in an XY plane. So, for example, if we were to move my particle here, if we said at time equals 2, the position of the particle is 3, it would look like that. Position of the particle is 0 at x equals 2. So that's just kind of like, it's just like where it is on the xy plane. So pretty simple, pretty basic with position. So usually though, when you're talking about calculus, they will give you a function for position, and they'll ask you questions either about distance or displacement. So what's the difference between those two? Okay, so distance and displacement. So I like to think of this as distance is movement without signs, and displacement is movement with signs. So what does that mean? So if we start at 0, 0, and our particle was moving. So let's say our particle moved 4 spaces to the right, back 4 spaces, here to -2, and then moved back to +2. So our distance, which we said was what? Movement without signs. We would count all of our movement back and forth. So that would be what? From 0 to 4 would be 4. From 4 to 0 would be 8. From 0 to 2 would be 2. From 2 to 0 would be another 2. And from 0 to 2 would be another 2. So you would add all of that together as positive. Even though we're moving in the negative direction, it is counted as a positive value because you're still moving. However, displacement, we're talking about the initial position and the ending position. We're not really considering, well, we are considering the movement back and forth, but we're just adding those as negative values so they cancel each other out. See, if we added this from 0 to 4, it was 4, yes, but then we moved back 4, that would be a -4 because we're moving in the negative direction. So this ends up just being from the distance from our initial to our ending location, which would only be 2 spaces, where our distance was much greater than that. Okay, so now on to velocity. So velocity is going to be the rate of change of the position. So what does that mean? So velocity in calculus terms is the first derivative of position, the rate of change of position. Biggest thing that when you think of velocity, the thing that's probably going to come to your mind is speed. And yes, speed and velocity are similar, but they are not the same thing. So velocity is like speed, but with signs. So speed, if you went 70 miles in an hour, your speed would be 70 miles per hour. It's still the rate. Velocity, you're dealing with positives and negatives. Speed, there's no such thing as a negative speed. There's no, like, you can't have a negative speed. And that's what we're going to show you right now in the car. This is the rate of change of the car's distance over a certain amount of time. This is the positive velocity since we are moving to the right or forward, and this is the negative velocity since we are moving to the left or in this case backward. Both have a positive speed though. So now you hopefully have a little bit better of an understanding of velocity, so we're going to do some practice calculus problems with the kind of questions you might see. An object's velocity is given by v of t is equal to 3t squared minus 12. Find the object's total distance traveled on 1 to 3. So total distance has to do with our position, and we are given velocity, which is the derivative of position, so we are going to want to do the definite integral of the velocity in order to get our position function. So, but before we do that, since we're talking about total distance, we need to find where the particle is traveling in the negative direction, so that way we can make that part positive, since distance, we are looking for everything, even if it's in the negative direction. So, we're gonna find that by letting the derivative equal to 0, so v of t equal to 0. And we're just going to factor out a 3. and then that would be t equals 2 and t equals -2. Our interval is on 1 to 3, so we don't really have to worry about that. So we are going to do a table of signs to find when the particle is moving to the left. And that's 2.5. That's going to be positive. No, my bad. That's going to be negative, and this is going to be positive. So over here, we are moving to the left. Over here, we're moving to the right. So this needs to be positive, and we're going to do that by putting an absolute value around it. So when we integrate, we're going to integrate by parts. Definite integral from 3. And we're going to put absolute value signs around this. And this is because, as we said, this was negative, so we need to make this positive before we can add these two together. So we're just going to do the normal thing you would do for
Then we'll find our antiderivative. And then we are just going to plug it in. And that's going to be, this is going to be 8 minus 24 negative 16 minus 1 negative 11, which would give us negative 5 plus, I'll rewrite that. This is absolute value. My bad. And then same here, we're just gonna plug it in. So we have 3 cubed minus 12 times 3 minus 2 cubed minus 12 times 2. And that's going to be 27 minus 36, negative 9 minus, we already did that here, our negative 16, which would give us 7. So, let me write that. Negative, absolute value of negative 5 plus the absolute value of 7, which would just give us 12.
So in this question it says, given a position of a particle is found by x of t equals t squared minus 6t squared plus 9t plus 1 when t is greater than 0, find when the particle is changing direction. So as we saw in our example, particle changes direction, the velocity has to equal 0. It has to pause for a brief moment before it can change direction. So we're going to be looking at when the velocity equals 0, or even if you could look at it like changing direction, changes sign, which is a critical value. So we're going to be finding the velocity. So x of t is equal to t cubed minus 6t squared plus 9t plus 1, and then v of t is equal to 3t squared minus 12t plus 9. So we're going to set this equal to 0. Let v of t equal 0. And we're going to solve for t. Let's factor out our 3. And then we're going to factor this, which would be t minus 3t minus 1. So when t is equal to 3 and when t is equal to 1 is when our velocity is equal to 0. So what we also have to check is the acceleration, because if there's nothing changing the velocity at a certain point, if the acceleration is equal to 0, then how could it be changing directions if there's nothing propelling it in that direction? So we're going to check and make sure that at these points the acceleration is also not equal to 0. If it's equal to 0, then we have an issue, but if it's not equal to 0, then we're fine. So a of t, so that's the derivative of this, second derivative of this, so that's going to be 6t minus 12, and we're just going to plug in each of these for t. that's going to give us 6, and this is going to give us -6, so neither of these are equal to 0, so this is where the particle is changing direction. You could even use this method to find when the particle is moving to the left, velocity is negative, or when the particle is moving to the right, velocity is positive. Okay, and last but not least, we have acceleration. So acceleration is the rate of change of the velocity. So what does that mean? So velocity, I'm just going to put this in something you might understand more. So velocity, like we said, is kind of similar to speed. Well, how does speed change? Speed can increase, speed can decrease. So like that, velocity can increase, velocity can decrease. So in calculus terms, this means that the acceleration is the first derivative of the velocity, and acceleration is the second derivative of the position. So to give you a better understanding of what this means, let's go outside to the car. As previously discussed, the rate of change we are changing is speed. As my mom accelerates the car by pressing on the gas, the speed increases, or we have positive acceleration. As she presses on the brake, the speed or rate of change decreases, and we have negative acceleration. So, a common question that they might ask you in calculus is to identify when a particle is speeding up or slowing down. How do you know when this is? Well, a particle is speeding up when the acceleration and velocity have the same sign. A particle is speeding down when the acceleration and the velocity have different signs. Why is this? Let's go back out to the car. Here we are speeding up because the velocity is positive and the acceleration is positive. Here we are also speeding up because the velocity is negative and the acceleration is also moving in the negative direction. Here we are slowing down because the velocity is positive and we are moving to the right, but the acceleration is negative since we're using the brakes. I hope you enjoyed my video on particle motion.
Okay.